Why, hello, advanced geometry students. It is I, Mr. Donaldson, and I'm here today to talk with you about section 1.7, which is circles. Now, you may be asking yourself, why the heck are we going back to chapter 1? We've already done that. Well, you may remember, but probably not, that we skipped section 1.7 because since chapter 6 is all about circles, we figured why the heck not just wait until then to introduce all this vocabulary since we haven't used any so far. So that's the plan. Today's lesson is just circle vocabulary. So first of all, what's a circle? So, in class, we would have this whole big discussion about what you thought the definition of a circle was, and it would be fun, and I would tell you we're all wrong, and it's just such a nice lesson. But sadly, we're not there, so I'm just going to give it to you. First of all, you guys, this symbol looks like an O with a little point in the middle of it. Just represents circles. So you can't just do this for a circle, because it might be an O or a 0, so you got to put a little point in the middle. So the technical definition of a circle is the set of all points in a plane that are equidistant to a given point. So we start off with some given point. We're on a plane, this flat surface, and you just put all the points that are the same distance away from that one. And if you filled in every single point that was the same distance away, you would eventually get a circle. And I know that drawing is terrible. And also in a plane, because if you didn't say in a plane, then you would be talking about a sphere. Think about like a basketball or something, right? So in the plane part is really important. That given distance that all the points are away from that center point is called the radius. All right, so here's my circle, all those points that are the same distance away. Wow, that's really bad. Let me try that one more time. Here we go. Perfect circle. Ready? Go. Oh man, that's actually not terrible. It's pretty good. But anyway, that given distance that every single point along the circle is from this point, it's called the radius. And then this point right here in the center is called the center. So, name the center of the circle. So if I look over here, the center is the point in the middle there. So we would just write simply K. Name the radius. Now I know up here we talked about the radius as a distance. And really it's all about the context. Radius could be a distance, but it could also be a segment that shows you, or that's drawn from the circle to the center. So when I say to name a radius, I want you to actually give me a segment. So like segment BK. But if I gave you, like, let's say I put a 5 here and I was like, what is the radius of the circle? You'd be like, oh, 5 inches or whatever the units were. So pay attention to the context. Sometimes I'm asking for a segment. Sometimes I'm asking for a distance. The way you name a circle is you name a circle using its center. So this one over here is Circle K, just like the convenience store. So I'm just going to use the little circle symbol and put a K. And then I know if I look at a diagram, oh, you're talking about this circle with the center K. And then the last thing is, like, if you see a drawing and you see a dot or point in the center of that circle, you're allowed to make the assumption that that is in fact the center. Because, like, for instance, if I had this picture drawn and I put a point right here, you could argue, like, well, how do I know for sure that's the center? Maybe it's not quite perfectly in the center. And so just remember, I'm not here to trick you. So if you see a diagram like this and there's a point that is obviously, supposed to be the center, you can assume that it is. Like in this example, we can assume that K is definitely the center of that circle. All right, so here are some definitions. First is a chord. So a chord is a segment, all right? So not a line, not a ray, but a segment. So it has 2 endpoints, and those endpoints lie on the circle itself. So let's go ahead and we'll draw a chord CD. So to draw a chord, I'm just going to put 2 endpoints anywhere on the circle. How about here and here? And then I'm going to draw a segment that connects those 2 points. So, boom, there is chord CD. Next, a diameter. A diameter is a chord that contains the center of a circle. So it's still a chord, its endpoints are still on the circle, but it contains the center, which means it needs to go through the center. So if I want to draw a diameter CE, I'm going to start at C, I'm going to go through the center of the circle, and I'm going to put point E over here on this part right here. There we go. There's my diameter. All right, tangent. A tangent is a line that is coplanar with the circle, so it's got to be in the same plane, all right, that intersects it at exactly 1 point. So in this one, we want tangent tangent AB with point of tangency A. And that point of tangency also is the point where that point of intersection of the tangent in the circle. So where the tangent intersects the circle. So if I want tangent AB with point of tangency A, I'm going to call that point A. And I'm going to draw a line because by definition it's a line. So I'm going to put little arrows on the end of it. And it would look something like this. There's my tangent. Touches the circle at one point A. And we wanted to name it AB. So I'm going to put another point B on there. And then the last thing is a radius KA. And a radius goes from the center to any point on the circle, but it's not a line. Oops, let me change this to a segment. So KA is my radius. There you have it. So that's a chord, a diameter, a tangent, and a radius. Again, this unit, this lesson, it's all vocabulary, so pretty straightforward. And as you're doing your homework assignment, it's just like, do you understand the vocabulary? So look back at your notes or look at the textbook or whatever's easiest for you. All right, so next thing is congruent circles. And you guys, at this point, hopefully should just know what that means right away. We've talked about congruency a lot. Remember, congruency are just two objects or figures or whatever that are exactly the same in every single way. So really, the only thing that makes a circle unique is the size of the circle. And what determines the size of the circle is the center. So, or excuse me, not the center, the radius, I apologize. So what determines the size is the radius. So if I have this circle right here, and then I have one that is congruent to it, that just simply means that they both have the exact same radius, that the radii are congruent. All right, so I think those look pretty congruent to each other. So like if, whatever this length was, this circle over here, if it was congruent to it, would have that exact same length radius. So I would say, like, let's call this one circle A and circle B. It makes sense for you to say, hey, circle A is congruent to circle B. And what I can conclude from that statement is that they have the same radii or radius. All right, concentric circles. Concentric circles are coplanar circles, so still on the same plane, that have the same center, but they have different radius. So check it out. Kind of looks like the target symbol. Oops, I want the same center. That was not quite the same. Let me try a better job. There we go. So here I've got right now 3 concentric circles. Let's go for a 4th concentric circle. Those are all concentric circles. Same exact center, in the same plane, just different sizes. All right, so next, a central angle. A central angle is an angle whose vertex is the center of the circle and whose sides contain the radius. Let's talk about the wording of that thing. So I'm going to draw a little circle here. So it's an angle. Now an angle by definition has a vertex, which is a point, and sides that are rays. So this is a central angle, right? Because an angle is technically defined to have rays as its sides. But typically when you see a central angle, we don't really see the arrows on there, because typically our diagrams tend to be confined to the circle itself. So typically a central angle would just look like this. All right, and it just has that vertex at the center. All right, then arcs. So arcs are part of the circle. So check this out. When I say the circle, I'm talking about all these points. Remember, the circle is the set of all these points. That's a circle. Now an arc is an unbroken part of a circle. So for instance, like this would be an arc. All right? Or maybe this would be an arc. So there's 3 different types of arcs that we talk about. All right? First, an arc that is less than half the circle, like this green one. We call that a minor arc. And so a minor arc's measure would be less than 180 degrees, because all the way around the circle is 360, so less than half would be less than 180. All right? And if you kind of follow that same naming logic, more than half would be called a major arc. So this is a major arc, more than half the circle. And then the last one, you guys, I know it's still an arc, but we don't have arc in its name. You guys probably know this. But when you've got an arc, and let me just draw another circle here so I can demonstrate this. When you got an arc whose endpoints are the endpoints of a diameter, So I know the wording, you just got to really think through this. Let me draw a diameter. And an arc whose endpoints are the endpoints of a diameter. Notice that is half of the circle. This is going to be a semicircle. Now, really important for you to know, when you're naming arcs, this is really crucial. All right, minor arc you use 2 points, major arc you need 3, and a semicircle you need 3. And I can explain to you why pretty easily. Let me put some points around this guy up here. If I just said arc AB, because I only used 2 points, it is implied that I'm talking about a minor arc. So it is implied that I'm going the shortest distance from A to B. So in that diagram, arc AB is my minor arc. A major arc, you need a 3rd point, because if I just said AB, you wouldn't know to go around this long way. So to name this yellow major arc, I'm going to call it arc ACB. To say, hey, I'm going to start at A, I'm going to go to B, but I'm going to go and stop through C along the way. So you got to use 3 points to name a major arc. And then with a semicircle, let's see if I can do this one here. It wouldn't make sense for you to just say arc XY, because I wouldn't know to go around the left side or the right side, so you need 3 points as well. So in this case, if I want to talk about this highlighted semicircle, I would say arc XZY. All right. So let's just identify some of these in the diagram. There's more than one answer, okay? So maybe you pause here and you try to answer them yourself and just see if you get the same thing I do. All right, so here we go. A central angle. A central angle is just any angle that has its vertex at the center. So you have a lot of options here. I'm going to call, how about angle AFE? All that matters really is that F, the center of the circle, is the vertex of your angle, and it's right in the middle. All right, a minor arc. Minor arc we name using 2 points, and it's less than half. So how about I go with arc AE? And make your arcy, or your arc arcy. All right, try not to make it too segmenty. A major arc. Major arc is more than half the circle, and you need 3 points. So maybe I start at E, and I go around through B, all the way to D. So I can't just call it arc ED, because I would then go the short way around. So I'm going to call it arc EBD. So then I know I got to make a little detour and go from E through B to D. And then finally, last thing is 2 different semicircles where there's only one diameter drawn here. So I've got the one on the left, which I'll call maybe EAC. That would be the same exact semicircle as if you named it EBC, because they both start at E, go around this way to C. And then the other semicircle here would be EDC. Booyah. All right, and then the last little part of this thing is just arc measures. So the measure of an arc is defined by the measure of its central angle. And the measure of a major arc is 360 degrees minus the measure of the minor arc. And I'll show you what that looks like in a second. And the last thing here is the measure of a semicircle, always 180 because it's half a circle. And this little m means measure. So find the measure of arc ED. So I want to find the measure of this arc. And by definition, the measure of an arc is equal to the measure of its central angle. So if this central angle is 90 degrees, then the measure of this arc is 90 degrees. So arc ED is 90 degrees. Find the measure of central angle AFE. Well, by definition, the measure of a central angle is equal to the measure of the arc. So if this minor arc is 30 degrees, the measure of that central angle is 30 degrees. Find the measure of arc ACD. So from A through C to D. Now check it out. It's everything except this 90 and 30 from 360. So I'm just going to do 360 minus 120 degrees, because that's my 90 and 30, which gives me 240 degrees. And then the last question here is find the measure of arc EDC. You'll notice that is half the circle, so that's just 180 degrees. All right, guys, that's pretty much the vocabulary and the basics of circles. We're going to get a little bit more into it with the Chapter 6 units. So have a great day, and if you have any questions, let us know. And with these notes, and the textbook, you should be great to go for the homework. All right, take care.